hi there. This may be specific feedback for you. Oh no, I've lost my internet. Specific feedback for you, or just very similar to the problems I'm seeing with this particular question. So I thought I'd do it in a video for you. So let's just parse the question. We know that we have the parent function f of x is equal to x squared. So let's write that down. F of x is equal to x squared. So this certainly can't be f of x because we're told what f of x is. What's the equation of the transform function? We might call it g of x or h of x, some different function. Anyhow, let's continue. There's a vertical reflection, so I'm going to go through. I know a is less than 0. That's how you get a vertical reflection. If I want this to do that, I have a is less than 0, like negative number. Then a horizontal. That means k is equal to 2. Okay, k, not a, k. All right, and then a horizontal translation of 3 units to the right, 3 units that way. That means d is going to be like negative 3. Okay, it's going to be x minus 3 inside the machine of the function. And then finally, a vertical translation of 5 units up. C is equal to 5. So you see, it looks like the student is correct here. And this may be you, okay? It looks like the student is correct here. They got C is 5. They did plus 3, but it's not in the correct place, okay? And then they did minus 2 out there. That's like the A and K together. They're not the same, and they can't be used in the same way, all right? One little tip here is that f of x is equal to x squared. If anyway, no, never mind. That tip doesn't apply. So let's here's how you check your answers. Okay, here's how you check your answers. Is I'm not angry with anyone. I'm just like, this is what you do. This is, you check your answer now, and you write it into Desmos and see if it looks good. Okay, so here is f of x is equal to x squared, x to the 62. I must have my keyboard in the French mode. Yeah, there we go. X squared. There we go. And now let's get another line. We'll do g of x and write the student's function. What did they have? Negative 2 x squared plus 3, all in brackets, plus 5. Negative 2 bracket x squared plus 3. Oh, that's weird. That made it go down for some reason. I thought it was going to make it go left. See, it's wrong. Okay, it's not correct. I'll show you correct in just a second. Plus 5. Well, that certainly wasn't translated up 5. It wasn't compressed horizontally by 2. It was stretched vertically by 2. That's different. Let me show you why it's different. This point here is like been stretched 2 down that way. But this point here has not been stretched in that way by factor 2. It's different, okay? I'll show you the correct one. H of x, and I'll do it on the paper first. This is how I would do it. So I'm going to take my numbers here, a, c, k, and d, and put them into a function. So I'm going to have f, but it's negative f because I want to reflect it, of, and then I put my k inside there, 2x, put this in brackets, minus 3, bracket, bracket, plus 5. That's where they go in function notation. Now, if I say this is equal to h of x, like my transform function, then my equation for h of x is equal to negative bracket x minus 3 bracket squared. Notice that looks a lot like, I really wish this would go away. Notice that really looks a lot like vertex form of a parabola when we shift the vertex 3 to the right. It's the same, okay? And then plus 5. This will be correct, except I'm missing something. I'm missing this. Oh my goodness. I'm missing this k is equal to 2. Okay, I'm missing that k is equal to 2. So this is not correct. What I do want to put in there is that h of x is equal to negative bracket 2x minus 3 bracket bracket squared plus 5. There. The k should be factored out. It should, but still multiplying the input. And it still is, this is the machine of the function, right? Here's the function, that's its machine. And the k and the d are exposed to that machinery. The A is not. The A does not get squared. The C does not get squared. Okay, so those are outside the machine of the function, A and K, A and C. See, they're outside the machine. K and D are inside the machine of the function. So let's take a look at that in Desmos and see if Mr. Jennings is right. This is equal to negative bracket 2, bracket 2, bracket x minus 3, bracket squared plus 5. Okay, this one has been squeezed by factor 2. I know that because look at this. This is goes here to here. See, that was the point like there, where it went over 2 and up 4. Now it goes over 1 and down 4. So it changed the x value, not the y value. It's actually the equivalent of an A transformation of 4 or a K transformation of 2. They happen to be algebraically the same because you square the K. 2 squared is 4. Okay, so there's a similarity with quadratic functions. That similarity between A and K does not necessarily continue to other parent functions, but in this case it does. Anyway, so I'm right. Okay, there, it's right. That's what it should look like. Okay, so it's a long explanation, I know. And this is tricky, I know. I wish we had 4 months for this course. So that's your fault for choosing to do it in summer. This is like the busiest course in high school, and you're doing it in a month. So I salute you and your hard work at trying to learn all this stuff at once. Don't worry, you'll get time with your advanced functions teacher to go through all this step by step. Or send me emails and I'll send you videos. Bye for now, everybody.